Hi, and welcome to this course on battery safety. Battery safety is becoming so important now, and that's because of a rapid increase in electrification that we're seeing in our transport system, in electric vehicles, in aerospace, in defense, in telecom sectors, in portable electronics. A lot of different industries are taking on more and more portability in devices, wearables, right? A lot of new devices are coming up in the market every few months that are using batteries. And one of the most used battery types now is becoming lithium ion. And the reason for that is because it is so energy dense. Energy density means that lithium ion batteries can pack a lot of energy, a lot of usable energy in a smaller amount of space and a lesser amount of weight. Now, whenever we have a situation like that, when we have a lot of energy in a small amount of space and a less amount of weight, then we're looking at if there was a failure that was going to happen, if it were to happen, then the energy that will be released rapidly. And that's because so much energy is contained in a small amount of space that when it does release in a non-controlled way, it tries to release rapidly. Right? So through this course, we're going to understand how to contain such a failure. How do we contain that, isolate that fault, and stop it from propagating to a larger failure? Right? To do that, we're going to first understand what is inside a lithium-ion cell. Right? What is it constructed of? How is it manufactured? How are different types of lithium-ion cells manufactured, like pouch, prismatic, coin, button cells, and also your cylindrical cells, right? How are these different types of cells manufactured? And what are the inherent safety advantages and disadvantages of these different types of cells? And once you have a chosen type, for example, once you've chosen that your product's going to be based on a prismatic cell or a cylindrical cell. Now, in terms of going from that one cell to a 10 cell pack to a then 100 cell pack, or in other words, you can go from one cell to a module, a bunch of cells, and a bunch of modules, then going to a pack. What are the different types of faults, or what are the different types of errors that can creep in this assembly process of cells? So first, understanding how a cell is manufactured, what are the errors or the faults that can creep in during the manufacturing process. Then understand that once we have the cell with us, and then we are assembling from a cell to a module and a module to a pack, what are the errors that can creep in through the assembly process, right? Which can then propagate to larger failures later. And then looking at a product from a product design perspective, whenever you are designing a product that is based on a battery, running on a battery, which could be electric vehicles, which could be portable electronics. Whenever you're designing such a product, what are some of the things that you need to keep in mind during the design phase of the product that is going to be using a battery as its main energy source, right? And then we're going to look at case studies, very important case studies of failures that have happened in the past, very recent past. And these include Samsung Note 7, your Boeing Dreamliner failures, looking at failures of battery factories burning down, Tesla cars catching fire, other electric vehicles catching fire. So trying to see that when these kinds of faults occur, what are some of the things that we can learn from errors that have happened in the recent past so that they don't happen again, right? And then what are the things that we can incorporate into different parts of the cell life cycle, into our product design phase? What about internal testing? Right, internal testing of a product in different use cases, where we're going to be looking at SAE standards, we're looking at IEC standards, ISO standards for testing. What do they dictate? What types of internal testing can you perform before a product reaches out for certification and then eventually in the hands of a consumer? Now, this course is going to be super valuable for students, for professionals, for managers, for quality assurance, for supply chain, people in supply chain, for people looking at businesses surrounding uh, devices using batteries, right? A whole plethora of disciplines and professionals from students that are gonna get involved in the design phase and the overall life cycle of products, battery related products. And as I said before, these battery related products are gonna become more and more part of our everyday lives, as we've already seen the trend. But the forward trend is also that the batteries are going to become more energy dense. So it's not just the number of devices that are using batteries, but it's also the density of batteries. Energy density of batteries is increasing, which means we're packing more energy in smaller amount of spaces and lesser amount of weight. That means we got to be more careful with that, right? So students who are graduating from electrical, from chemical, mechanical, system, software fields, they're all going to be at some point in their career looking at a battery related portable device. So it becomes very important to understand the failure mitigation, the failure analysis, the life cycle of product development of lithium ion cells as well, to make sure that you are putting this knowledge to good use when you are sitting on with your laptop or with a pen and paper and designing a new product, or looking at why a product failed, or trying to make sure that a product does not fail in the user's hand, and any type of failure that is creeping in is caught in with the internal QA departments. How do you make sure these kinds of things and checks are put in place with the right knowledge early on, right? So super important for students, super important for professionals who are getting into the design or the quality assurance, or looking at supply chain management of battery related devices, portable electronic devices, electric vehicles. Even if you are currently in this field, what are some of the steps that you can take to increase your knowledge and increase your understanding of why things fail or why battery related devices fail? And having this knowledge, let's give a simple example. The Samsung Note 7, right? It had a failure, a battery failure that cost the company millions of dollars. Now, if you were on the design team and if you were able to find this fault on why the battery failed and why it caused such a big failure, it would have saved the the loss to so many consumers that saw this failure, where the phone actually burnt next to their face, right? So these are kind of things you don't want to see your consumers to go through. The amount of financial loss that the company went through, the amount of brand loss that the company went through, the amount of lawsuits that the company had to go through because of this. So having that kind of a knowledge early on and being on the design teams for such important products becomes very useful after taking this course, right? So this is what the course will try to try to teach you on how do you mitigate these kinds of issues, right? So in terms of in terms of the Samsung Note 7, it was an internal fault in the cell that was caused due to the edge of the battery being too close to the edge of the phone, right? We're going to be looking at this in more detail in the case study that we're going to do on Note 7. But such kind of insights that you can have from recent failures, from other failures that have happened in different industries, and an insight on how the lithium ion cell looks like from inside, right? What does it look like from inside? What are the different steps that are taken on the cell manufacturing side? What are the steps that are taken on the pack assembly side? Having a view of that can help you almost have an X-ray vision of a portable device or an electric vehicle. And having that X-ray vision will allow you to spot errors in the safety performance, or the potential failures that can happen that other people might not be able to spot because they don't have that type of an insight, right? So that's the intention through this course. And even for managers, business owners, to look at this as a not something to be scared about, as we will be seeing more and more batteries more and more energy dense batteries being used in our devices. So it's not something to be scared about to use in your products, but having the right knowledge is how we can prepare when a failure does happen. How do we reduce the impact of that on the consumer, on our company, on the overall financial implications, and the overall health implications that could happen by not having a properly designed product, right? So having the right knowledge, having the right experience will allow you to then make full use of this really good energy source that we have in front of us, which is the fuel for tomorrow, the fuel for today, which is lithium-ion batteries. Right. So let's proceed with the course and learn about how do we make lithium-ion batteries perform safer in our devices.